This is lesson 6.4, Inequalities in One Triangle. And we are going to take a look at our triangle with an exterior angle and think back to how we talked about these two inside angles add up to the outside. So if both of those add up to the outside is going to have to be bigger than 3, and the outside would have to be bigger than 2. So the two inside are actually going to be smaller than the outside. So we're going to identify each angle measure that would be less than 7. So if 7's my outside, I'm going to look for my two remote interior, which would be this one and this one. And it technically could also be, if we're looking at it kind of like a big triangle versus a small, it could be 1 and then kind of the combination of 2 and 4 as well. So all of these angles I've just circled in red are going to have to be smaller than angle 7. So we have angles 1, 2, 4, 5, and then I would even include 6 as well because 7 is obtuse and 6 is its supplement. So I would definitely say 6 would also be one of the smaller angles because of that. All right, so now which angles must be greater than 6? So again, we just said that I think 7 is because it's obtuse. And so bigger than 6, if we look at 6 and 5, the remote, or technically 6 and 1, there we go, the remote interior for 8 being the outside one, these two being the remote. So 8 would definitely be bigger than 6 because I think 1 plus 6, yep, would add up to 8. And then I think if we look at the other kind of, all right, kind of crossing off some of this and just highlighting this red/blue angle here, or triangle, using 6 and 4 as the two remote interior. 3 would be the exterior, even though I know it's a part of this triangle and still kind of inside. But if we just focus in on this triangle here that's surrounded blue and red, 3 would technically be the exterior of this if we kind of ignored all the rest of it. 4 and 6 being the remote interior. So I definitely think that 6 is smaller than 3. So it's saying which of these must be greater than 6. And I would say that 3 is definitely going to be greater than 6 because it's going to be the exterior of kind of that triangle. All right, it's hard when we have multiple triangles, so kind of focus in if you can. The longest side of a triangle is always opposite the largest angle. And the shortest side is always opposite the smallest angle. Okay, because, excuse that, because when our angle gets bigger, that side across from it is going to get longer, right? And when it's a small, teeny tiny angle, it's a small side that's across from it. So angles and sides have a relationship to each other. So of course the largest angle is going to be opposite the longest side. The smallest angle across from the shortest, there we go, side. So let's practice that. Here we go. Looking at our sides, again, I'm not going to have you name sides when I already give you the lengths. That is just, you could literally do that in kindergarten. What's the smallest side? I think my daughter could probably even do that. And so you would say PR. No, we're going to find that side, but then we're going to give the angle. So it's still easy, but you have to find the relationship. Which angle is the smallest? We're going to put that first, so Q. And now we go to the next, which is going to be the 8.8, and it's across from R. And then, of course, across from 9.1 is P, which is the longest side, so largest angle. So now we're going to go across from our angles and find the shortest to longest side. So here's my smallest angle. It's across from AC, which is my shortest. Then 55, which is going to go and be AB. And then we're going to go 80 and we're going to go BC. And there we go. So I want you to try B. You do have to solve for your missing angle first, and then you can go ahead and put those sides in order. So push play to check when you're ready. The missing angle is 67. So the smallest is going to be across from the 50, which is BC. The next is going to be across from 63, which is AB, and the last one across from our 67, which is AC. All right, so we're going to go ahead and compare Lynn to Logan. All right, so we're going to see what they're across from. So if we look from Lynn to Logan is this segment here, which is across from, our unknown angle. So let's go ahead and find it. 180 minus 76 minus 39, which is going to get us 65 degrees. 65 degrees? Nope, let's double check that math. Yep, it is 65 degrees. Okay. So then we're going to look from Manny to Logan. There it is. And that's across from 76 degrees. So who's closer to Logan? Meaning who has the smaller angle, because that would be the smaller distance. So it would be Lynn. Lynn is closer because he has the smaller angle. Right, on our bicycle, we have two angles. Let's go ahead and find that third angle because we want to compare AB, which is across from our unknown angle, which we'll find here in a moment. And we want to compare that to AC, which is this segment, which is across from 44 degrees. So let's do our 180 minus 82 minus 44. And then we will figure out that that is 54 degrees. And that is bigger than 44 degrees. So AB is a longer length than AC. In this last section, you are going to find the largest angle, which remember, if we relate it to our two remote interior, the biggest is going to be the one outside. So I'm going to kind of highlight here my triangle that has to do with 1, 5, and 6. 5 and 6 are my inside. 1 is the outside. So 1 would have to be the largest angle. Now I'm going to look at 4, 5, and 7. So 4 and 5, and there's 7. So the one outside is the bigger one. The two remote interior, those add to get the exterior. So try that last one, looking at 3 and then 12 and 11. And hopefully you just circled angle 3 because it's the outside compared to the two 12 and 11 that are inside.